Chapter 4: Our Fine-Tuned Universe. The cosmos is the entire physical universe, that which is visible and invisible to us. It contains all that ever existed. Our universe is also controlled by four forces of nature: gravity, the electromagnetic force, and the two nuclear forces. Our existence completely depends on these forces, as well as some other conditions that make our universe very special. If any of the conditions or forces were just a bit different, we would not be here to talk about it. Our universe is also intricate and delicate in many ways. We see that forces and conditions, including fundamental constants that describe the forces, are finely tuned. Galaxies, stars, and life-sustaining planets could never have existed if, say, gravity and the electromagnetic forces were just a bit different, or if the nuclear forces were just a bit different. This characterization of the universe is referred to as being finely tuned. Fine-tuning is seen in stars, a place where life is actually created. The nuclear forces control the rate of nuclear fusion in stars, the energy source for all life on Earth. It's the creation site for the essential element of life, carbon. The four forces of nature must be as they are so that carbon can be produced at a rate that makes this element abundant in the universe. But there's another quality of our universe that we do not understand. As a matter of fact, it begs us to ask the question how we could even be here. But something happened 13.8 billion years ago, something we call the Big Bang, where all matter, space, and even time began. How could this have all happened out of nothing? Scientists like to use the concept called entropy to help answer this question. No. Although entropy may be a difficult concept to grasp, it is somewhat akin to how things are arranged. The more something is in disarray, the more entropy. The more order, the less entropy. You might think of entropy in terms of a messy office, a place where entropy is very large, or a well-ordered office where entropy is low. Apart from the fact that a clean, ordered office is a nice place to work, we all know that it takes energy and effort to clean an office. If left to its natural state of affairs, an office will become disordered. Naturally, entropy always increases unless there's a concerted effort to reverse this. Now, the entropy of the entire universe is increasing, though locally there are exceptions. The relatively well-ordered Earth, where life exists and humans are found, is an example where entropy is lower than in other parts of the universe. But this lower entropy is found at the expense of increasing entropy elsewhere. Which brings us to our universe, the very beginning. Before the initial expansion, before the Big Bang, scientists believed that the universe was a very small place, a size of some 10 to the minus 30 meters, incredibly smaller than the nucleus of an atom. In this tiny space, all matter, energy, and everything was in its lowest entropy state. Then the Big Bang occurred. Space expanded. Entropy increased. And for the past 13.8 billion years, to this very day, it has been increasing. The universe is becoming messier and messier. Eventually, all energy will dissipate, and likewise, entropy will increase to what cosmologists call heat death of the universe. A serious question comes to mind. How could energy have arranged itself in an orderly way for that moment just before the Big Bang, and all by chance? Everything was in the right condition in an incredibly low entropy state. The answer is somewhat surprising. Roger Penrose, a famous mathematician and physicist, has worked through the calculation to determine the probability of such a small entropy and how that could have spontaneously occurred at the very beginning. The probability is so small that we have a difficult time to even demonstrate this. One might say our universe should not be here. The probability of this is 1 divided by a huge number, a number far greater than all the particles of the entire universe. But fortunately, by use of stacked exponents, we can write this number down. So large is the denominator in this fraction that if written down with the font size as in the screen before you, it would not fit on a piece of paper where that piece of paper could fit into the known universe. So small is this probability that alternative ideas, including the ideas of multiverses, or an infinite number of universes, has now become popular. We'll address this in upcoming chapters. But as we end this intro into Chapter 4, it is clear that science simply does not have an answer to the following. Why the universe appears to be so finely tuned, so that all forces are set up as they are, and how the Big Bang could have occurred with such low entropy, or perhaps more profoundly, how the Big Bang has occurred, period. There are lots of questions. Is the Creator a reasonable assumption? How much faith does it take to believe that all this was out of pure randomness?